everyone, today we are going to learn about what is generator and how does the generator works. And sometimes this generator we call it as a dynamo. So a generator is actually converted your mechanical energy into your electrical energy. This mechanical energy is actually the kinetic energy in your turbine, which rotate by the other source of energy. It can be your wind energy, the heat energy, and also your hydro energy. So in Malaysia, the main generator uses the hydro energy to rotate your turbine and convert your kinetic energy into the electrical energy by using electromagnetic induction. So how does the generator looks like? Okay, there are two types of generator. The first type of generator is your alternating current generator, and the second type of generator is your direct current generator. So for the alternating current generator, it will generate alternating current. Was the direct current generator, it will generate direct current. So for generator, it uses the principle of electromagnetic induction to convert your mechanical energy into electrical energy. So when we say about electromagnetic induction, so it comes to the mind that magnet must be inside this model. So we have magnet in this diagram. In order to produce your magnetic field, a permanent magnetic field, while in between this magnet are the coil. This coil will be rotating in order to cut your magnetic flux. So we know that electromagnetic inductions induce EMF when there is a rate of change of magnetic flux. Thus, the coil have to be present and rotate so that the magnetic flux can be changing all the time. So this coil, you notice that this coil are attached to two things like this. So these things we call as slip rings. So these slip rings are actually made up of metal rings, which is used to conduct the electricity from the coil to the main circuit. So this one is your main circuit. Okay, the blue part of your coil is attached to your blue slip ring, while your yellow coil is attached to your yellow slip rings. So whenever your coil is turning, rotate, rotate, and rotate, it will still attach to the same end of your main circuit. So the blue one is always attached at here, and your yellow one is always attached at this part. Okay, you get what that means? So this is your main circuit. When we say about main circuit, is actually this. This is your main circuit, which is, you can consider it as a circuit that transfer the electric energy to your house. So this main circuit is connected with the slip rings by using the brush. Why? Because your slip ring is always rotating as your coil is rotating. Thus, we need a brush to connect your slip rings and your main circuit so that it can conduct electricity to the main circuit. Okay. Now for DC generator, so if you look carefully, the DC generator is also made up of two magnets. Okay, the permanent magnet in order to produce the magnetic field so that there is an electromagnetic induction happen. Then of course your coil must be rotating so that there is a change in magnetic flux, and induced EMF can be induced inside your conductor and produce the induced current. So the yellow part of your coil here will be attached to this type of rings. So what is this ring called? This ring is different with the AC generator rings. The AC is a slip rings, which is a metal ring, but a split ring. Same like as its name, it will be split half for this circular metal rings. So this metal ring doesn't connect to each other. The yellow one is with the yellow one, the blue one will connect to the blue coil. So if you look carefully here, so this blue split rings were connected to the blue coil. Okay, while the yellow coil is connected to the yellow part of your split rings. Of course, because your split rings is always rotating, thus it needs brush to connect it to your main circuit. Okay, why there is a difference between your AC, which is using two slip rings, while DC is using split rings. So later on, I will explain how your AC generator generate AC current, and also your DC current generate DC current. Okay. Before I start to explain the working principles of your generator, the AC generator and also DC generator, the first thing you must know is to determine your directions of your induced current that's produced inside your conductor. So for your direction of induced current, we can determine by using two methods. The first method is your Fleming's right hand rule, which you can find in this link, or I have already put this link in my description box. The second method is by using your right hand grip rules. I also have made a video for this method, so you can refer to this link, which I already attached this link in my description box. So before you proceed to to continue my video, please look at this two video first. If you happen to be already know how to determine the directions of your induced current, then you can proceed my video. After you have learned how to determine the directions of your induced current, you may proceed my video. Here I'm going to start to discuss or explain the working principle of your AC generator to generate the AC current. So to start to explain my AC generator in generating the AC current, I will split this into four parts or four diagrams so that I can explain it one by one. So for the first diagram, you notice that for the coil here, so it is actually attached in this position, which is in horizontal position. So this coil is placed between the magnetic bar, which will have the direction of magnetic field pointing from north to south pole. So your B is pointed to the right hand side. Well, your coil will be rotating, let's say rotating in clockwise direction. So if this coil is rotating in clockwise direction, you will notice that the blue conductor here, or the blue part of your coil, will experience an upwards motion. So your V is pointing up, while your P is pointing to the right. So you have your directions of your P and B. Now you can determine your direction of your induced current using right hand grip rules. So let's take a look on this small video. Okay, now look at how do you determine your directions of your induced current using a right hand grip rules. So for V is pointing upwards, so your forefinger is need to point like this upwards, and then your B is pointed to the right, which is your direction of the magnetic fields pointed to the right. So you cross your fingers like this. Okay, V is upwards and then B is like this to the right. So you have your thumb pointed into the page. So when you have your thumb pointed into the page, means that your current is moving into the page. So you have your blue conductor, which the induced current is conducting or flowing into the page. So what is into the page? So if you look at this right bottom part diagram, you will notice that into the page is look like this. So for into the page, for blue conductor, here is actually moving from, let's say I make a note here as a point C and here as a point D. So your current will be moving from point C to point D. Get it? Okay, now you know that the conductor or the coil is rotating in clockwise direction. Thus, your yellow conductor will have the motion that is pointing down. So your B is actually pointing downwards, and your B is still pointing to the right hand side. Okay, now I will show you another video on how to determine your induced current for the yellow conductor.
Okay, for this one, you have your B moving down, which is downwards. So your coil is moving down and your B is moving to the right. So I will move our palm into the right. So when you cross your V cross B, V cross B, you get your thumb pointing out of the page. So pointing outwards. Okay? So you have your induced current pointing outwards for this case.
So means that for your yellow conductor, you will experience a induced current that is flowing out from the page. So your I is flowing out from the page. So notice that out from the page is actually look like this. So your yellow conductor will experience current flowing like this direction. So I let here to be point E and here as point F, means your current will flow from E to F. Okay, from E to F. In other words, if you look carefully for this diagram now, your coil will flowing, the induced current will flowing from C to D and then from E to F. So in other words, the current from the main conductor, it will come up from the yellow part of your slip rings and then it will conduct and flowing back to the blue slip rings. So in other words, your main conductor will experience a clockwise direction current flow. Okay, a clockwise direction current flow. So means that your current is flowing from here, the yellow part here, which I attach, which your main circuit is attached to your yellow slip rings and flow into the blue slip rings. So your I is conduct from your yellow slip rings to the blue slip rings, which is in clockwise direction. So your I is flowing in clockwise direction. Okay, now if your coil is turning into 90 degree, another 90 degree, so now your coil is turning 90 degree. After 90 degree, your coil will be in this position. So the blue parts will move up 90 degree, then your yellow part will move down 90 degree, and you get these positions of your coil. Still the same, the directions of your B is pointed from north to south pole, which is to the right. But for your blue conductor, due to the coil is rotating in clockwise direction, so now your blue conductor will experience a motion which is to the right hand side. So V is pointed to the right and B is pointed to the right, so both are in same direction. So at this moment, when your coil is at this positions, so at this position it happen to be no cutting of any magnetic flux. So if there's no cutting of magnetic flux, here I is 0. No induced currents flowing through the coil. Now for your yellow conductor, it happens to be moving to the left hand side, or your V is pointed to the left hand side and your B is pointed to the right hand side. Still, at this moment or at this position, this yellow conductor is in the same plane or opposite direction between each other. So here there is no cutting of electromagnetic flux, thus I is equal 0 ampere. So in this case, we have generator that doesn't produce any induced current flow to the main circuit. So I for the main circuit is 0 ampere because there is no induced current being induced through this process. So now, if the coil move or rotate another 90 degree, so now your coil will be in this position. Your yellow conductor will move up 90 degree and it will position at the left hand side of your coil, while your blue parts of your coil will move down and now position at the right hand side of your coil. So still the same, your B is pointed to the right hand side because from north pole to south pole, but now your blue conductor will experience a downward motion due to the clockwise direction. So you will experience B pointing downwards and B is pointing to the right. So refer back to the first diagram here. You know that when you have V pointed down and B pointed to the right, you will get an induced current that is flowing out from the page. So in other words, you can determine by using a Fleming right-hand rules and also right-hand grid rules. But because we already determined in the first diagram, so I just keep this part. So we have I that flowing out from the blue conductor. So we have I at here. So this is point C, this is point D. So it's flowing through from point D to point C. Well, for your yellow conductor, because of the coil is rotating in clockwise direction, so your yellow conductor will experience a upward positions. So the upward positions, you will have V upwards and B pointing to the right. So compared to the first diagram, we get that the current is flowing into the page. So means that for the yellow conductor, we have I that flowing from point F to point E. Okay, so now if you notice this, okay, if you notice that your current is still flowing in clockwise direction for this case inside the coil, but because of your Y, yellow coil here is attached to your yellow ring, so means that the current is flowing from here and then go inside the coil and then it come out and into these blue slip rings and then it will go back to the main circuit. So means that your current now is flowing in this way for your main circuit here. Okay, here. So in other words, your circuit now is flowing in anti-clockwise direction. So your current will flow from the yellow rings, go into your yellow coil here, and then pass through the coil to the blue coil, and then blue slip rings, and then come out to the main circuit. So means now you have your anti-clockwise direction as compared to your first diagram. As compared to your first diagram here is your first diagram. you notice that the directions of your current in the main circuit are opposite in direction. So it will generate the alternating current. So now, if the coil continue to rotate 90 degree again, so now it rotates 90 degree again, so the coil will look like this. Your blue coil will move down and your yellow coil will move up. Still, your B is pointed to the right hand side because from North Pole to South Pole. Okay, but now your blue conductor will experience the motions to the left hand side, so your B is pointed to the left, but your B is pointed to the right hand side. Since they are opposite in direction, so there is no cutting of electromagnetic flux, there is no cutting of magnetic flux, so no induced current at this moment or at this position. Well, for your yellow conductor here, your yellow conductor will experience motions to the right hand side, so you have V pointed to the right hand side and B also points to the right hand side, so both are in the same direction. So at this position, so there's no induced current flow inside the coil. So in other words, in the main conductor or main circuit, no induced current is generated. So later on, your coil will continue to move or to rotate. So it will move back 90 degrees and back to the first position. So this is a continuous process. So it will continue to generate the AC circuit current or AC current. So in other words, I can use the diagram to represent the AC current. So look carefully with my yellow part here. So let's say for the first diagram, you have your I as a maximum. Then for the second diagram here, this is your second diagram. So this is your second diagram. You have 0 induced current. So this is this is time. And then for the third diagram, here is your third diagram. You have your maximum I, but in different positions, so it will be different with the first diagram, and later on it will get another 0 here, then it will move back to positive direction. So you will have this type of current flow through the circuit. So this is actually your alternating current. The induced current that flowing through your AC generator will be different according to the positions of your rotating coil. So if your rotating coil is parallel to your magnetic field, or your V is parallel to your magnetic field, then you will have no induced current inside the coil. So in other words, this is due to your changing in induced EMF in an AC generator. So how does your induced EMF change? And how do you calculate your magnitude of your induced EMF? So in my previous video, I've already taught you about what is Faraday's laws. So according to your Faraday's law, electromagnetic inductions, the EMF that induced in this process will have directly proportional to your rate of change of magnetic flux linkage, which is N d phi dt. So N at here is your number of coil. Okay, well, phi here is actually your magnetic flux, which is BA cos theta. So B is your magnetic field strength, A is your area with your vector area, and theta is the angle between B and A. So theta is your angle between B and A. So if we refer back to this diagram on the left hand side, so when your coil is rotating in clockwise direction and your magnetic field is pointed to the right, which is pointed to the right from North Pole to South Pole, the angle theta between your B and A will be here. So your A is always perpendicular to your plane of your coil. So this is your plane of your coil. This is your plane. So when for A is always perpendicular to a plane, so your A is in this direction. So the angle theta is actually here. Okay, this is your angle theta. So for this one, you have your first equation and second equation. So when you substitute equation 2 into 1, so you will get induced EMF equal to N d dt. You differentiate your BA cos theta. Well, because you want to differentiate your BA cos theta with respect to t, but you doesn't have t, so you know that angle for this case, your coil is rotating with an angular velocity which is equal to omega. So you will have theta equal to omega t. Okay, your coil is rotating in a fixed rate which is omega. So theta will be equal to omega t. In other words, this equation can be written as n BA cos omega t. Okay, after you differentiate your BA cos omega t, so your EMF will be equal to N BA negative and BA sine omega t. In other words, you can be written as negative N BA sine omega, sine theta. So your theta is the angle between your B and A. So this is how your magnitude of your induced EMF calculate based on the changing of your angle, because every single second your coil is rotating, so your angle is always always changing. So now I give you the first case and the second case. For this case, when your plane is in this position, okay, if your plane is in this position, so your A will be in this direction because it's always perpendicular. So your plane is in this position, so your A will be perpendicular to the plane, so you will get an upwards A. So A is upwards, still your B is pointed to the right, pointed to the right. So in other words, the angle between your A and B is a 90 degrees, so your theta will be equal to 90 degrees. So the induced EMF in this generator and this positions, the coil, the plane of your coil in this positions will be equal to negative NBA sine 90 degree. So you notice that sine 90 degree is actually equal to 1, so your EMF will be equal to negative NBA. So this shows you the maximum EMF. So means that when you are in this position, your A and B are in 90 degree, so your induced EMF will be the maximum EMF. Well, for the next diagram, which is this diagram, so when you have this diagram, you know that your coil is rotating into this position. So now your A is in this direction. Okay, your A is in this direction. Wait, because you cannot see clearly. So your A is in this direction. Okay, which is perpendicular to your plane. Your plane is in this direction. So your A is in horizontal. And your B is still pointing to the right. So in other words, angle between B and A is 0 degree. So your theta will be equal to 0 degree. So in other words, your EMF will be equal to negative NBA sine 0 degree, which sine 0 is 0. So EMF at this position will be 0 volt. So that is why there's no flow of induced current in these positions of your coil. So you will get a changing of induced current and also the magnitude of induced current based on the changing of the angle of your coil. So are you clear about this induced EMF, the magnitude of induced EMF? So get to know that and remember that when your angle between your A and B is 90 degrees, then you will have the maximum induced EMF. Well, if your angle between A and B is 0 degrees, then you will have the zero induced EMF. For the DC generator, we know that the coils are attached to the split rings. So the blue part of your coil, the blue conductor, will attach to the blue split rings, while your yellow conductor will attach to your yellow split rings. Still, your B will be positioned from the North Pole to South Pole. So we have B pointed to the right. So let's say now your coil is still rotating in clockwise direction. So it's still rotating in the clockwise direction. You will notice that for your blue conductor, it will have a positions that move upwards. So your V will point upwards, while your B is still pointed to the right. So by using a right hand grid rules, so you can try your own now, or you can using your Fleming right hand rules. So you will get that your current is flowing into the pitch. So for your blue conductor, the current are flowing into the pitch. So I label here C and D. So you have your current flowing from C to D. So in this case, you know that the current is flow into the blue conductor. Okay, into the blue conductor. While for your yellow conductor, you will experience the downward positions or downward motion. So your B is in downward motion, but still B is still pointed to the right. So by using a right hand grid rules of Fleming right hand rules, you can use it your own. So I didn't show you now. You just practice it your own. So you will get that your current is flowing out from the pitch. So in other words, it's flowing from point E to point F. Okay, from point E to point F, which is in this direction. So means that it will flow from the yellow conductor D to from C to D and then E to F, then it will come out from the yellow split rings and flow in this direction. So now your current is flowing in clockwise direction. Okay, so it's flowing into clockwise direction, so your I is in clockwise direction this way. Okay, now let's say your coil is again rotate into that 90 degree compared to the first diagram. So it will rotate in this position. So after 90 degree, it will rotate in this position. So for this positions, your B is still pointed from left to right and it still rotate in clockwise direction. So the blue conductor will experience the motion to the right, which is your B pointed to the right and your B is pointed to the right. So B and B are in same position. So in this case, I is not induced in this conductor. So there is no current flow. Okay. Well, for your yellow conductor, the motion is to the left. So you will get B is pointed to the left and still your B is pointed to the right. Due to B and B are in 180 degree, so your I is still 0 ampere, means there is no current flow. So I have explained this in your previous slide. Y is I is equal to 0 ampere. So means that there is no current flow in these positions when your plant is rotating into these positions. So now again your coin rotate again 90 degree. So it will change into this position. So now your yellow is at the left hand side, while your blue conductor is at the right hand side. But your B is still pointed to the right, and coils are rotating in clockwise direction, so your blue conductor will experience downward motions. Your V will pointed downwards, your B is pointed to the right. So in this case, by using a right hand grip rules or Fleming right hand rules, you will get your current flowing out of the page. So for the blue coil, so if you look carefully, this point D, this point C, so your current is flowing from points D to C. So it will flow out to the blue split rings. So it will flow out from the blue split rings, and then it will rotate in an clockwise direction. Okay, it will rotate in clockwise direction. So it will flow from here, flow out from the blue split rings. So this is your I. Well, for your yellow conductor, it will experience a motion which is upwards. So you have V pointed upwards and B pointed to the right. So in this case, we know that I is flowing into the page, which you can determine by using a right hand grip rules or Fleming right hand rules. So you will know that, you will get that your I is flowing into the page. So in other words, okay, I label here as E, here as F, so your current is flowing into the page. So flowing in the main circuit is flowing into the yellow split ring. So if you look carefully, so in the main circuit is still current flowing in clockwise direction. So in other words, for this case, you have both here, the first case here, we look at this first case, okay, wait. The first case here, the current is flowing in clockwise direction. Then for the second case, no current is flowing. And then this one is still flowing in clockwise direction. So it means that there is no changes in direction. So this is one direction of current only. So we call this generator as a DC generator. Okay. Now, again, your plane of your coil is rotated 90 degrees, then you will get this type of diagram. So for your blue conductor, it will move to the left. So you have your V positioned to the left, while for your B is positioned to the right. So this has no current flow through it because they are 180 degrees to each other. Well, for your yellow conductor, your motion is to the left, right. So your V is pointed to the right and your B is pointed to the right. So both are in same direction, so there is no current flow through it. Okay, so if you look at this four diagrams, so they are always moving from the first diagram to second diagram and the third diagram, fourth diagram, and back to the first diagram in a rotation form. So you will get the current that flowing in one direction. So for the first one, you have positive, then 0, the second diagram, then again positive maximum, and then fall back to 0. So you get this type of current or induced EMF. So this is known as DC current, direct current. Okay, so that's it for today's lesson. So I've already taught you how and what is the working principle behind your AC conductor and DC conductor. So thank you for watching this video. See you in the next lesson.